ರೆಕಾರ್ಡ್ ಆಗತ್ತೆ ಅಲ್ಲ ಆಮೇಲೆ ಹೆಂಗೆ ತೊಗೊಳಲ್ಲ ಆಮೇಲೆ ಎಲ್ಲ ರೆಕಾರ್ಡ್ ಆದಮೇಲೆ ಹಾಂ ಕನ್ವರ್ಟಿಂಗು ಹಾಂ ಹಾಂ ಆಮೇಲೆ ಮಾಡ್ತೀಯಾ ಪ್ರಣವ್ able to hear me? Pranav or Upa? All right. ಇಲ್ಲ ಭಾವನಾ Yeah, we'll start the class. Mahima, yes? Mahima?
Yes, sir.
Yes, sir. I will start the classes. Okay.
Yes, sir.
I will start. Yeah, I will start the classes. Exactly, the conversion of the continuous AWG channel into vector channel. Okay, so as I mentioned already that what is exactly the conversion of the AWGN channel into vector channel. The output of the AWGN channel, as I told you that we are going to choose the additive wise Gaussian channel because 8 possesses the constant noise, but it is independent of the frequency. Right. So that means we, in order to transmit the charge between the transmit and the receiver, we are going to set the AWE channel. The noise is constant. Noise, it does not vary along the channel from the transmit to the receiver and over the frequency signals. That means that noise, the information what you are going to transfer, it is only added with some noise, doesn't vary as the signal progressing from transmitter to receiver through a channel. The output of the channel, absolutely, we are taken into what output is equal to transmitted signal is equal to what? Output signal. During this channel, the white noise will be introduced. The white noise we call it as, it is an integration of the so many noises absolutely present in the channel, as simple as the light, we've got integration of this most of the colors. White light will have the colors. So now, as we told that this output will be goes to the receiver. In the receiver, it will analyze the S of t, Si of t along with white noise. Please mind it. Si of t and white noise will be analyzed in the receiver initially in a two factors. The first factor, observe that the information we are getting is absolutely correct. What is exactly that is two factor will be done by our receiver. One is observing the signal, second is estimating the signal. What is exactly the observing the signal? Please mind it. Si of 2 is equal to, will have a subset of a signal, S1 of 2, S2 of 2, up to Si of m. Similarly, Xi also will have Xi1, X2, X1 of 2, X2 of 2, X2 of 3. This information will comes to this, whatever this, here exactly input. The input will analyze, first thing to first observe whatever the subset of a signal is, was received at the input is correct. How it will going to check? As I already told, there is some clock frequency signal will come along before this information from the transmitter to the receiver. This clock frequency will be checked by the receiver, but the frequency of this clock frequency will be mapped with or clock frequency of the at the transmitter. If it is exceeds that, then it will go for estimation of SIT at the input. What is exact estimation? Because as I told you is SI of t will also have S1 of 2, S2 of 2 up to SI of n. Okay, exactly. We'll have a subset of a signal. Each subset of a signals will be analyzed, taking S1 whether it is having received is correct. How it will be checked? For as I mentioned it, SI of t will be checked with the probability of signal is error, what we call M1, M2, M3, like exactly in the rows, and column will have subset of a signal received at the receiver S1 of 2, S2 of 3, S of 3. See, these exactly, this a matrix will come anytime. Each element will be multiplied, each element will have Si of j along with the basis functions. Si of j is the element of the, what is the number you receive. Basis function will help you to check out whether the received information is correct. Once this M into N matrix comes here, this will absolutely plotted into the what exactly Elicidian signal space to know the energy of the signal. In order to energy of the signal by using Elicidian theory, it calculates the energy by the length of this vector. So you look back, Elicidian spaces will be have pi j and pi, because as I mentioned already clear, the Si of j will have pi j and pi I. This is vertically the y-axis in the Elicidian space will have pi j and pi. With this value, we will able to draw a signal. The length of the signal will is equal to what exactly? Is equal to energy of the signal. That's what exactly gone through. That means what the information coming in a continuous, that is this, we are converting to what exactly in a absolutely in a one angle. It may be when you plot this initial signal, it may comes in the one angle or it may comes in the other angle like this in one direction, one magnitude. That is why we call it as vector channel. So please mind it, conversion of the continuous channel into vector channel. Energy, whatever the signal is coming for continuous, will be converted into what exactly? Vector. So when you receive the information through probability of signal, so that means we are going to corrupt. Look back what really does happens. When you see look back geometric representation, and we have studied for gram schematic organization, this is, if you look back, the Si of t which is received as the input will be checked whether the received is correct with the help of the basis function, what exactly? Pi j and pi I, exactly pi I and pi j, right? The pi and j, this pi and j, that means look back here, S1 of 2, S2 of 2 up to Si of t. Similarly, we'll have output signal is equal to X1 of 2, X2 of 2 up to Xn, something like that. That means is S1 will be exactly mapped with what you call it X1 of 2 with the help of what you call it as bias functions. Okay, exactly here. So look back what bias functions. That is why that means output is also concerned with what exactly bias function. We represent the output of the signal is here like this, right? This output of the signal which over X of t is also considered biasing over a time period. See, this is if you say output, as I mentioned in the first pages already, this output has to match with what exactly input and go by a macro input and input signal plus what I call Gaussian noise, which is absolutely what is which is given by this equation Sij. Already know that channel noise is equal to 0 to 2 W2 pi j of dt into 5. So this is what we know already. This is equal to this. This is equal to this. But when you come back to this, as we know from graph schematic, this gives the mathematical representation, or also it gives the calculation of the energy of the signal at any point in the elucidance point. How we are going to calculate? This is absolutely, this is the equation. Graph schematic equation is given by G of IT of this along with pi of j. This is the pi of j values. This is G, this is a G of IT. Pi of IT is equal to this much. Look back. Therefore, this is by using this equation, the any output, because as I mentioned, it's exactly here. As I mentioned, is the output is considered a set of set of signals, set of output signal x1 of 2, x2 of 3, x2 of this. So that means any one of these we have to find the energy of the signal. This energy of the signal will be found by the receiver to check whether they are correct after from the matrix into the what? Elucidant space. From the elucidant space, we are going to find what exactly energy of the signal. From the energy of the signal, what exactly the receiver understand that receiver understand the receiver understand whether the received information is correct or not. Okay, so from this subset, one of the, this is exactly what you call it as x of t will be exactly, look back, x dash of x of t is equal to what exactly? Pi of j x of t. So this is one of the sub values by using the what exactly? This equation. This by using this equation exactly here when okay. Okay, this is exact. This is the by using this equation, any one of these things, I'm going to get it. See, x of t is an output. We know that input and output. Substitute this back, and we'll get back to this. Just substitute, and Si of t is equal to what exactly? Si of, okay, exactly Si of t. Si of t. This just multiplication. We'll get back the input, and when input get cancelled out, okay, exactly. When the input get cancelled out, the some noise is here. See, look back. Noise is exactly in these cases pi j and pi of j. Okay, exactly. Right. This is pi j. This is exactly pi j. This is okay. Look back here. See, this is get cancelled because over the noise is always zero. Which we mention it in very clearly mention it. The average of the noise because it's a constant across from this. This is zero. That is over that. There's any that means exactly you can say any sample of the output is depends upon the noise. That means signal will be constant and the now output signal will get affected by the noise itself. Please mind it this equation. And when you come, this is the equation. Look back here. So just multiplying this equation. So this is the sample of. This is the exactly. So this is the output. Input at the AWG channel. White noise at the channel. Therefore, the received signal at the receiver depends upon the, so that means exactly the receiver signal is input at the AW channel, white noise at the channel. The received signal at the depends upon the both the same. Look back here, this is the input at the AWG channel is a very constant because we have mentioned we are sending set of signal is a constant where exactly a noise is the only factor which gets. But definitely we have mentioned in AWG channel that the noise is constant throughout from the transmitted to receiver till that receiver via channel, but still have some extent noise is changes due to some internal and external factors. That means this output of the what you call it as AWGN channel system, okay, exactly it changes as output changes as it progresses from channel to the channel from this transmitted to the receiver via channel. That means that noises get changes randomly as it progresses from transmitted to the receiver. As it progress from the exactly the receiver as per this equation. That means we can say this is the equation which is behaves in a random nature, unpredictable, because noise is exactly changes as it progress from this point. So that means we need to analyze this equation in the random nature or stochastic condition. What is exactly stochastic condition is the one which absolutely gives the information how exactly it gets changed. it get a change. That is why we need to analyze this equation. Absolute this x of t is equal to input at the noise is has to be changed at what you call it as with the static parameters. Okay, exactly. Now, okay, that means what is exactly static characterizations? See, x of t is equal to, we'll have x1 of 2, x of 3 up to that n of. So we'll have x of t, any one of these in a subset values. Take small x of t, here look back, small x of t. In that one value will be taken as a sample of the, one of the values output will be taken as a sample, that is x of t, capital X of t is a sample, which we need to analyze absolutely, which I mentioned in the last pages, exactly what in terms of the statistics parameters, like because the statistic parameter like average, standard deviation, mean deviation, and distribution factors and variance, because since that equation will accordingly move changes in accordance with the what random in nature, and hence we have to analyze that. That is, we have taken, that means x of t I have to analyze in a random. When you say, when you define the x of t, that is a one of the subset of the small x of t, x1 of t, stuff like that. So absolutely one of the random variable I'm going to use it. That random variable we call it as x of j. That random variable I'm going to use to analyze the x of t in a random nature. This is one of the part of the what x of t's. Okay, exactly. Look back here. When you say x of j is the what analyze, similarly wj is also noise. Okay, exactly, which is also in a random nature, because you mentioned, I mentioned it, x of t is equal to output of the input of the signal plus noise. This noise, okay, exactly, is also random in a nature. Output is also in a random nature. Okay, exactly. The overall noise, we look back here. So that means the wj random error like see. See, look back here. What is exactly here? So what are the factors we need to find in a random? So when you say something is a random, that means changes as is time from point to point. So we need, when I said, let us say this is exactly channel at one point, I need to determine what is the value. I need to take an average effect of this plus this over this point. I can determine what is the value of the function at this point. That means when I want to analyze what is exactly the noise is affecting on this channel at one point of view, we need to take the average of the noise along the full channel from transfer to the receiver. And similarly, we need to analyze how this function varies as point to point. That means two factors we need to analyze in any random function. One is the mean and the variance. What is exactly the mean? Mean values gives the variation of the noises from point to point. Variance will give the exact variation of the noises at point to point. So that means whenever the transmitter the signal, this is because we have mentioned it as per gram symmetric, output signal is mainly affected by the noise because input is constant. As I mentioned is background, the last page, last but one page I mentioned x dash of t is equal to wt. So I need to analyze of that with the noise with the help of mean and variance along the what channel from transmitter to receivers. Okay, exactly. So x of t, x of j, w of j. This I need to analyze. Look back how we are going to take. So look back here. We need, let us two factor I'm going to analyze. One is mean, second is variance. What is exactly the mean? Mean is absolutely given by mu of e of expectation into what exactly? E of j, x of j. X of j is a sample of output signal. Okay, exactly. So one of these x small x of t is equal to one of the values there. That value is called x of j. Okay, x of j is equal to what? This is an output. If you say output, it has to be the input plus noise. Just substitute back to this xi of j. We'll get back to this equation. Look like I already explained this and this. This is mu x of phi and e x of phi. Will absolutely the mean of the x of phi will get you zeros. That is input value. The variance function use the, okay, exactly the variance function use the variance. That means variance of, I mentioned it. So that means at any point of the time, the average of the, at any point of the channel, at any point, the average of the signal is depends upon the what? Signal does not depend on the noise. Noise get cancelled out. Please mind it, very important fact. Average indicate the effect of everything at one point. As we know, very primitive basic definition of that. So that means average of signal at one point of this thing is only depends upon the what? Noise of the signal. And similarly, variance of the function various noise in the channel is given as sigma xj square variance xj. Xj is equal to what exactly? X of j minus w. Same thing, this equation. We are going to mention of this x of, okay, exactly here. Xi, this is xi minus yj square, sorry, si j square. Substitute back to this equation. We'll get back to what? Wj from this equation, I'm just substitute back. And what exactly? Noise is over a time period, which we have already proved that this is also as function. Put it across to this a into a square, because we divide is has to be a square. We are divided into what? Two scale j and k, and j and absolutely k values here, j and u values. Okay, exactly. So since that both are within the one limit, we have changed actually interchange the integration and this one. See, look back at w2 w are different two different function. When you say two different function, we need to analyze with the help of what exactly their effect on each other will be analyzed with the help of the autocorrelation function. That is exactly R of tu is equal to autocorrelation function only on the time levels. So when the autocorrelation function is given by spectral density of what exactly into del of this R of tu n naught by 2 del of t minus I, just substitute back to this. We're back and substitute the value of this is absolutely this value is equal to what? N of t is equal to constant taking outside from that when pi of j square. So look back, this is absolutely is concerned with what? When you say pi of j is equal to 1, you look back, the variance of the signal which is moving along this XL n of by 2. N of by 2 is equal to, as mentioned in the white noise, is a white noise spectral density which is given by this. That means what exactly you can say, pi of that is variation of this only depends upon the what exactly the noise spectral density of the noise, and mean of this depends upon the signal. Please mind it. Xi of t is output. Let me repeat your one sentence. Xi of t is equal to what? Why Xi of t is equal to input plus output. Input is absolutely depends upon the what? Input is absolutely depends upon the so many input. It depends only when the input is depends on the value. Noise will be introduced. Since noise is a random nature, output has to be absolutely analysis with respect to random in nature. What we are going to do with the random in nature, two factor we are going to analyze the random in nature, any function along this anything functions. With here, when you consider with the digital communication point of view, when the signal is flowing from transmitter to receiver, I need to analyze each function, how exactly it get changed while moving with the help of the noise, because since the noise is more with the help of the two parameters. Number one is the average, average mean. Second is what I call variance. When you so far we are deal with noise, what I call exactly the what you call average of the signal is flowing across the channel is equal to what absolutely depends upon the what signal only. So at any point of a time, an average of the signal at any point of the channel, it is only signal. The variance, that is point to point go along the channel, it only depends upon the what exactly spectral densities. Okay, look back here. What is that is since 2 xi of 2, that is absolutely we have mentioned it, xij x of k. So look back here, very clear. What you call it is pi j and pi k, that is what you call it a wj wk. It means that x of j and x of k. Understand that, because wj and wk, okay, will be terms of the noise with respect to wj with respect to the noise of x of j, one of the here, and wk is one of the noise with respect to what x of k. X of k may be within the x of j, or it may be the one of the terminal, let us one of the terms of one of the subset of the output signal. When you take a covariance of this, that means when you say two functions are not related to each other, how affect on two together, because we need to find out how exactly the signal is absolutely affected, because since while flowing from the, since we have divided noise into two functions, that's said, so we have to find with correlations here exactly the look back. This is the x of j minus Vx. This is the value you're going to x of j, and this is the substitute as per that I already mentioned the last pages. And this xij and xik is equal to this much. See what a covariance xj xk is equal to what? 0 to integral w2 pi j w2 pi of d 0 to t w2 pi of t. When you substitute, because noise is value of this, because since look back from covariances, and we substitute this to value, this is because changing the integration, we can change the integral because within the sum function. And here again wj and wk are in the different relationships. Apply the autocorrelation subject, as autocorrelation subject is talks about, since one is as equal to tu, substitute back at this value is equal to what exactly? This value is equal to 1 exactly. So look back, we get covariance x of j. Look back here, this value becomes 1 at u is equal to j. This means this is 1 this term, and ultimately become what n of 2 is equal to what? Zeros, because since I is equal to 0, very important, please mind it, why we got it 0 by this equation. Look back this equation, because look j and k are different, cannot be equate. See, look, for as per this equation of a signal representation, this gives 1, V I is equal to what exactly? U is equal to J, 0 is equal to what? This value. When you multiply this, the variance X of J is equal to this, statically independent together. That means variable exactly we can mention is exactly here. Variable X of J implies the statically independent to each other. Okay, exactly. So now as of this is we got it. That means you please mind it. The covariances, that means whatever the signal is flowing, even a subset of a signal will be analyzed with the average of the signal at average at any point, which is depends on one the signal. Variance will absolutely analyze the signal is flowing from one point to one, how exactly it gets varies. So look back that which we got it. Mean is only dependent on noise and variance dependent on noise. That means signal is always going. Noise is the factor which varies from point to point, which is clearly from statistical analysis. So look back now, let's come back to the how exactly the analyze goes. So far what we are learning, we are learning whatever the so far in geometric representation, a stochastic condition, to symmetric representation, we plot into what Ellis-Surians. Okay, let us now look back here. Just mention here, I'm going a different angle. See, look, let exactly here, let us define the vector of n random variables. Absolutely look back, mean values is equal to variance is equal to 1. See, what is exactly now, see, as I told you, S1, S of t will Si of t is equal to S1 of 2, S2 of 3, so many things, so many subset of a signal will transmit it over a channel to the receiver. The receiver will use X of t. As in informally we are, formally we are, sorry, not informal, formally we are say that output is equal to X of t is equal to X of 1, X of 2. Each X of 1 has to be related to the S1 of 2, X2 of 2 related to it. So that means how exactly this will be done with the help of, say, let us say this is the output. This is the each bit of the output expected. This is the, let us say this is a signal received. This signal received we call it as capital X in the input of the receiver, in the input of this is transmitter channel, in the input of the receiver, whatever the information received for estimation purpose, for a calculation purpose, capital X of p is equal to X of 1, X of 2 up to this. This X of 1, X of 1 is a Gaussian random variable with mean value, as we mentioned already. Sij this. With the element of look back, with the element of X are statically independent, which can be expressed in the probability density function of that. Because as we mentioned, because since the X of the signal is constant, noises get various. As noises varies, we have to analyze with that of the probability density function. From the probability density function, we have to analyze the mean and variance along the channel. That is absolutely, that means this equation each can be expressed as a statically independent. We need to express what I call probability density functions. Okay, so that means, see, this is if you say the probability is function. This is one of the elements. Look back, what is capital X? I mentioned X1, X2. See, look back, even receiver is exactly, you can say receiver is this, input is the value and output is X of t, small x of t. Capital X of t is equal to what exactly? The input is equal to receiving. The input is equal to receiving. F of X, Rupa, X of capital X of I, M of I is equal to what exactly? J of N, okay, exactly. J of 1 is equal to F of xj, xj is equal to W and this much. This is probability density function, because please mind it exactly the information signal. Okay, exactly the information signal. Okay, the information signal, whatever the received, you have to analyze. You have to analyze in the form of, you have to analyze f of x capital X. You have to analyze each information with the probability density function. Look back, vectors x and x or j, vector, small vector and x j. So look back here. Small vector, see, look, capital vector, see, look back here, observation vector. Look, okay, exactly, we call it as capital X is equal to what? Observation vector. X of j, we call it as what exactly? This is vector j and small vectors. See, look, vector j and vector. See, capital X is the input at the receiver. Output is equal to x, small x of t. That is what we need it. But as soon as it comes, estimation process goes. So capital X is equal to x1, x2, capital X1, capital X2. Each x1, we have taken some value of this, we call as a vector j and scalar j, sample of random variable vector j, some sample in the vector j, and this vector x is equal to observation vector. Vector j x of j, we call it as observation vector. The channel that satisfy, we call it as memorialized channel. Okay, I hope you got it. What is exactly this? This is the input. Receiver is the value input. will is an estimation takes place in the receiver. The output x of t, the input is equal to capital X. Capital X is equal to what exactly? The input to the whatever the information received. There's a small x1, x2. This has to be analyzed with the probability density functions, because whether the receiver is not correct, since we are going to map, this receiver is going to map absolutely with the value of how exactly, with the help of the probability function M1, with the help of the what exactly basis functions. Okay, exactly. Here we have taken, since the probability with function, that means each capital X, that is an observation vector, that is an input vector, has been representation, the probability density, which is absolutely given by this. Vector X and Xj are simply here, we have mentioned here. As we know, this is absolutely, I mentioned in the last first classes, this is the Gaussian variable absolutely here. So that means this has to be changed with this here, this value. So look back here. So that means that whatever the probability density function, each element of the observation factor, we need to analyze a capital F, a small f of capital prefix fx with the probability density function. This is a Gaussian. As for the Gaussian which you mentioned, this is the value will be mentioned. Since look back here, the output of the channel has to be what? That is, if you say this here, the output of the channel absolutely concerned with what? Input, that is SI of t, that is a capital X, which is received so far at the input of the receiver, along with this noise. So that means this, since each SI of t with the probability function, we are going to analyze this value here exactly. The output of the output, this has to be with analyzing this and the noises exactly. Substitute back to this. See, look back, Gaussian noise variable, which is being considered zero mean, because I mentioned it, wherever when you take the noise exactly along the channel, it is absolutely zeros. So that means when you substitute this value, because since we are using the mean and variance, or the fact of the noise along the channel, which I meant, two parameters will characterize in the noise along the channel, that is mean and variance factor. When you substitute back to zero here, okay, we'll get back what exactly. This is absolute expectation. So look back, this is W to the Gaussian at a value of any time k. Look back, WT of at tk will well exactly is equal to zeros. Next is what exactly? When you subtract W2 is equal to 0 in the previous equation, we'll get back to this equation. Look back, pi of n of t. This is the exactly deduction of the this noise is equal to, this is what the output of the receiver x of t. Therefore, x of, we can conclude that the receiving signal x of t are the only data that useful from the decision making theory. We have left out pi n of 2 because look back here, we are left of the pi n of 2. This is, look back here, the formally we can signal detection in the AW channel is considered only on the projection of the noise into the basis function of the signal, affect the sufficient statics of the decision problem. The remember of the, what I call, remember of the noise is irrelevant. This is only a absolutely statement. You please mention here the output of the signal. Look back here. Now I can mention this is the receiver. Whatever the from the channel, we'll get back to what the input receiver, that is capital X, that is observation x1 and x2, x3. Each x1 information will be analyzed by each. X will be considered input plus noise. Each input, that is SI of J, has to be considered the probability density function and noise. Where exactly the noise is always zero as a mean point of view, every point of view. So x of t is concerned with this value only. Therefore, this is exactly we can say, right? So look back, likelihood functions, likely. So next class, I would like to take a mention of this class. Tomorrow classes, I am going to finalize what exactly. Okay, well, tomorrow I will be finished of your chapter number 2. Okay, exactly, because I have repeated very much of the classes for you people. I know what is the fact. So yesterday we had a meeting with one of very important. Please, everybody, listen to me. Okay. Hello. Please, everybody, listen to me very carefully. Yesterday we had it. Hello, everybody. Mahima, able to hear me? Kavya?
Yes, sir.
Please listen to me, everybody, those who are in the classes, because yesterday we had a talk with Josna also, please, because yesterday we had a talk with the HOD and the principal. There is a one online test will be given. Shortly, they're going to be announced by the test coordinator, Suryanara sir. Okay. So probably that second date will be announced in the next class. Before that, I will send first unit and second unit notes to you. Let us take the first online tests for only a first unit. That is the first unit which I come. Let us not to go for a second unit, but anyway, I'll send the two classes. And because VTU direction has been come to the college that the classes has to be conducted like online only, and remaining two tests is offline. So many things that decision has been made. And right now, please assume that first thing is there is one online test. In the coming days, the test, what you call it as, portion for the test is will be what exactly portion for the that will be the first unit. Please get prepared. Okay, very simple. I'll give. Don't worry about anything. I'll take care of you in every aspect because I have to do it. Because everybody has to do it because of the direction from the principal. He is acting into what acting according to the of the VTU. Please study the first unit. First unit notes will be sent very shortly, maybe another 1 or 2 days. Tomorrow I'm going to complete unit 2. Notes is absolutely good. I'm checking out. So don't worry about it. Once the class gets started. Definitely there is one month, probably 4 to 5 weeks as of now mentioned. 4 to 5 weeks there is a classes. Okay, regular classes. In that we can finish it off because since the notes is good, if you bring back, if you brought the notes and just compare whatever notes, and second unit will also become so plus easy, and unit 1 are absolutely completed. Unit 3 is quite easy. I'll start the classes probably from next what do you call it as Wednesday or Thursday. Okay, so that is third unit we can finish by another week. So by the end of this May 3rd, there is a lockdown. What is the last date of the lockdown? We can complete the 3 units. The first and unit second. Please keep remember 2 things. Online test will be there in the next week, or something like that. It will be announced. The test, what do you call it as online test data will be announced in these things, and assignment will be will be given by Edmodo very shortly. Please keep in mind assignment has to submit because of the direct online test Edmodo. Okay. Have a nice day. Tomorrow we'll come back to that, and notes will be given.